bronze of sensible age knows that when a metal rusts, it wastes away. It gets lighter and eventually disappears. Stop. I have not finished. Contain yourself, sir. There is more. In a recently published pamphlet by a brilliant young chemist, Antoine Lavoisier demonstrates that the iron combines with the air. It, in fact, becomes heavier.
Most impressive. I intend...
Now, whatever you intend, monsieur, I intend to be by your side. I will learn all I can about your science and become your worthy colleague.
Then let me show you how the iron combines with the air to form such a delicate union.
Tomorrow, monsieur. Tomorrow.
تعلمت ماري آن الكيمياء قرب زوجها، لكنها بحثت عن وسائل مختلفة لتساعده في عمله. تعلمت الإنجليزية لتتمكن من ترجمة الكتب العلمية المعاصرة، وتابعت دروس الرسم لكي تسجل بتفصيل كل ما يعملانه معا. كانت تدير المختبر وتمثل مؤسسة لافوازييه في المجتمع. كانت محور جهود البحث العلمي.
That is a terrible thing to say. You are a cheeky man.
This way, please, gentlemen. Monsieur, it is my great ambition to demonstrate that nature is a closed system. That in any transformation, no amount of matter, no mass, is ever lost and none is gained. Over here, please. This precise amount of water is heated to steam. This steam is brought into contact with a red-hot iron barrel embedded in the coals. From this end, we cool the steam. But interestingly, we collect less water than we started with. So clearly, we lose a certain amount of water. However, we also collect a gas. And the weight of the iron barrel increases. Now, when we combine these two increases, the new weight of the iron barrel and the gas we have collected, they are exactly equal to the weight of the lost water.
But is it atmospheric air, Monsieur Lavoisier?
No. No, because I am measuring it to the very last grain. I can see that it is lighter than the air around us. And, moreover, it is flammable. Voila.
Water is made out of hydrogen and oxygen. So what he had done is get the oxygen to stick to the inside of a red-hot iron rifle barrel. He was basically just making rust, which is oxygen and iron, but he was making the rust really quickly. Now that left the hydrogen, what he called combustible air, and that was just floating around as a gas. No mass had been lost, it had merely been transformed. And now he wanted to transform it all back into water.
This is only the beginning. In the next few months, I hope to demonstrate that I can recombine this combustible air with vital air and transform them both back into water. I will recreate exactly the same amount of water that was lost here in this process. It is my hope to complete the cycle, water into gas, into water, and not a drop lost.
For a long time, Lavoisier had suspected that the exact amount of matter, the mass, involved in any transformation was always conserved. But to prove this, he had to perform thousands of experiments, and he had to do the measurements with incredible accuracy. That's where his great wealth from being a tax collector came in. he could afford to commission the most sensitive instruments ever built. He became obsessed with accuracy.
لكن وسائل لافوازيه الصارمة في دقتها بدأت أيضا تثير غضب الباريسيين الجائعين المتذمرين.
Antoine! Oh, wake up, Antoine!
I'm sorry. What time is it?
It is almost time to receive Monsieur Marat. The Academy asks you to assess his designs. He claims to have made a great discovery. Oh, Antoine, have you forgotten?
Oh, God. There's another charlatan with an idea to peddle. God give me patience. Monsieur Marat.
Monsieur, I have invented a device which projects an image of the substance of fire onto a screen. You see? When a lantern is shone through a flame, we see a shimmering pattern above the flame. My device renders the substance of fire visible.
Have you collected it, this substance of fire? Have you trapped it and measured it?
Oh, no, but one can see it.
I'm sorry, in the absence of exact measurements, of precise observations, without rigorous reasoning, one can only be engaging in conjecture, so this is not science.
I am not given to conjecture, monsieur.
Really, no. If you will excuse me, I am extremely busy today, but thank you. Thank you.
So that is all? Then good day, monsieur!
Let me guess, Marat. The King's scientific despot has decreed that your invention does not conform to the version of the truth as laid down by the Academy.
Lavoisier. He talks about facts. He worships the truth.
Listen to me, my friend. They are all the same, the Royal Academies. They insult the liberty of the mind.
They think they are the sole arbiters of genius. They are rotten to the core, just like every other tentacle of the king. The people. It is they who will determine right and wrong.
Don't worry. In my next pamphlet, I will expose this persecutor of yours.
طوال سنوات قامت جماعة لافوازيه بحرق وقص وصهر وغلي كل مادة في المتناول. بيّنوا أنه إذا كان المرء دقيقاً في جمع كل الأبخرة والسوائل والذرور الناتجة عن عمليات التحويل فسيجد أن الكتلة لا تنقص. السوائل قد تتحول إلى غازات، والمعادن قد تصدأ، والخشب قد يصبح رمادا ودخانا، لكن المادة تلك الذرات الدقيقة التي تتشكل منها كل عناصر المادة لا تتبدد أبدا. وقد توج هذا الاكتشاف باستخدامهم المميز للكهرباء الساكنة لإعادة تركيب الأكسجين والهيدروجين كماء.
What is happening?
عندما انفجرت الثورة الفرنسية تم إعدام العائلة الملكية ورموز الطبقة الأرستقراطية بالمقصلة.
to the French revolutionaries of 1790, Lavoisier meant one thing and one thing only. He was the despised tax collector who'd built that wall around Paris.
وظيفة لافوازييه كجامع ضرائب سلطت الشكوك حوله. لقد أدانه جان بول مارات، العالم الفاشل الذي تحول إلى صحفي راديكالي.
Où est Lavoisier?
Je sais pas.
Lavoisier! Lavoisier! Lavoisier!
What Lavoisier did is absolutely central to science and especially T equals MC squared. Because what he said is if you take a bunch of matter, you can break it apart, you can recombine it, you can do anything to it, and the stuff of the matter won't go away. If the mob burned Paris to the ground, utterly razed it, shattered the bricks into rubble and dust, and burned the buildings into ashes and smoke, turns out if you put a huge dome over Paris and weighed all the smoke and all the ashes and all the rubble, it would add up to the exact same weight as the original city and the air around it before. Nothing disappears.
بعد قرن من ذلك الزمن تم تصنيف الطبيعة إلى نوعين: الطاقة، القوى التي تحرك الأشياء، والكتلة، وهي المواد التي تتشكل منها تلك الأشياء. علوم القرن التاسع عشر كلها استندت إلى هذين التصنيفين الأساسيين. القوانين التي كانت تحكم أحدها لم تكن تنطبق على الآخر، لكن أينشتاين الشاب حديث العهد بالفيزياء لم يكن يحب القوانين.
Good grief, Einstein. What happened to you?
It is more than a little ironic, having been reprimanded yesterday by that idiot Professor Pernay for poor attendance, that I should in fact attend a practical lesson, which was as long as it was boring and utterly pointless, by the way, only to be the victim of an explosion of my own apparatus.
So it was your own fault then?
Thank you. And how are you today, Fraulein Marriage?
Extremely well, Herr Einstein. All the better for seeing you have escaped the physics laboratory with your life.
Well, in order not to alarm you any further, I pledge to forever continue my studies here at the Café Bahnhof, reading only the great masters of theoretical physics and eschewing the babbling nonsense of the polytechnicians.
It's about all you ever do.
It's getting a little stuffy in here, Fraulein Marriage. Would you care to take a walk with me? There's something I'd like to discuss with you.
Why, Herr Einstein? Of course. Perhaps you'd like me to tell you what you have missed in lectures this week.
Einstein wasn't exactly a model student. He excelled in certain subjects, especially physics and math, but he wasn't very diligent in a lot of his other classes. He was undoubtedly very questioning, which seems to have annoyed most of his professors throughout his life. He would pursue his fascinations with just incredible determination.
We know from his letters that Einstein, even from the age of 16, was literally obsessed with the nature of light. everyone he could speak to, his friends, his colleagues, even his then girlfriend, Mileva Merrick, who would become his wife, everyone he badgered with the question, what is light?
What would I see if I rode on a beam of light?
What? A beam of light? By what method do you propose to ride on this beam of light?
The method is not important. Let us just imagine we two are young, radical, bohemian experimenters, hand in hand on a journey to the outer reaches of the universe, and we are riding on the front of a wave of light.
I really don't know what you are suggesting, Herr Einstein. Do you wish to hold my hand or ridicule me?
Ridicule you? No, never. I merely want you to help me to understand. What would we see, do you think, if we were together and we sped up and up until we caught up to the front of a beam of light?
الملاحقة المستمرة للضوء التي شغلت أينشتاين هي التي أحدثت ثورة في العالم. بالضوء أعاد تركيب النظرة إلى الكون وعثر على العلاقة التي تربط بين الطاقة والكتلة. الضوء يتحرك بسرعة تبلغ 670 مليون ميل في الساعة. لهذا استخدم العلماء حرف السين للدلالة على السرعة. قبل حلول القرن التاسع عشر بفترة غير قليلة استطاع العلماء رصد سرعة الضوء، لكن أحدا لم يكن يفهم ماهيته. في إنجلترا استطاع رجل أشرنا إليه سابقا تقديم تخمين مدروس. بعد وفاة السير هامفري ديفي أصبح مايكل فاراداي البروفيسور فاراداي أحد أهم الذين أجروا التجارب في العالم. كانت المؤسسة العلمية لا تزال ترفض فكرة أن الكهرباء والطاقة المغناطيسية إن هما إلا مفهومان لظاهرة واحدة سماها فاراداي الكهرومغناطيسية. مع ذلك كان عليه أن يقدم عرضاً أكثر إثارة لجمهوره.
Invisible lines that can emanate from electricity in a wire, from a magnet, or even from the sun. For it is my contention that light itself is just one form of these vibrating lines of electromagnetism.
بذل فاراداي جهده طوال 15 سنة لإقناع المشككين بأن الضوء هو موجة كهرومغناطيسية، لكنه كان يفتقر إلى الرياضيات المتقدمة لدعم رأيه. أخيراً جاء من يؤازره. البروفيسور جيمس كلارك ماكسويل آمن بصحة رؤية فاراداي البعيدة النظر، وكان لديه الطريقة الرياضية لإثباتها. وهكذا أصبح ماكسويل والعجوز فاراداي صديقين حميمين.
James, forgive me. A word of advice. Don't get old.
Michael, how are you?
I'm fine. Memory isn't too good. But...
Well, I thought you might like to see what I've just published.
Oh, yes. Yes. Splendid.
So your results show that when electricity flows along a wire, what it actually
actually does is create a little bit of magnetism. And as that magnetic charge moves, it creates a little piece of electricity. Electricity and magnetism are interwoven, like a never-ending braid. So it is always pulsing forward. It's wonderful. Wonderful. Michael, there's something very crucial in maths. This electricity producing magnetism and magnetism producing electricity, it can only ever happen at a very particular speed. The equations are very clear about it. They come up with just one number. 670 million miles per hour.
I'm not sure.
It's the speed of light. That is the speed of light. You were right all along. Light is an electromagnetic wave.
أثبت ماكسويل أن فاراداي كان محقاً. الكهرباء والمغناطيس هما مظهران لوحدة أعمق، لقوة تدعى اليوم الكهرومغناطيسية، تنتقل بسرعة 670 مليون ميل في الساعة. أما بشكلها المرئي فهي ليست أكثر من الضوء نفسه.
She's very pretty.
Yes. But can she soar and dance like our dark souls do?
Maxwell's equations contained an incredible prediction. They said you could never catch up to a beam of light. Even if you were traveling at 670 million miles an hour, you would still see light squiggle away from you at 670 million miles an hour.
Do you see how she stares at that wave?
Yes.
You see how for her it is static?
Yes.
She and the wave are traveling at the same speed. We see the wave moving through the water, but relative to her, it just sits there. So is light like that?
Common sense would say that if you caught up to a light beam, there would be a wave of light just sitting there. Maybe it would be shimmering, a bit of electricity and a bit of magnetism.
So, if she was traveling alongside the light wave, it wouldn't be moving, it would be static. But Maxwell says you can't have static light.
Maybe Maxwell is wrong. Maybe if you catch up to light, it is static, Albert, like a wave next to a boat.
Imagine if I was sitting still and holding a mirror to my face. And the light travels from my face to the mirror, and I see my face.
Yes.
However, if I and the mirror were traveling at the speed of light...
You're going at the same speed as the light leaving your face.
Exactly.
The light never reaches the mirror.
So would I be invisible?
That doesn't make sense.
كان أينشتاين الشاب قد بدأ يدرك أن الضوء لا يشبه أي نوع من أنواع الموجات. كان على وشك دخول عالم تتداخل فيه الطاقة والكتلة وسرعة الضوء بطريقة لم تخطر في بال أحد، لكن كان هناك جانب رياضي يحتاج أينشتاين إليه، وهو عملية التربيع الرياضية اليومية. قبل الثورة الفرنسية بزمن طويل لم يكن العلماء يعرفون كيف يقيسون الحركة. كانت المعادلات التي تشرح حركة الأشياء واصطدامها بدائية. أما المساهمة الهامة في هذا الموضوع فجاءت من مصدر غير متوقع. أعرفكم بالأرستقراطية، ابنة أحد رجال حاشية الملك لويس الرابع عشر، إيميلي دو شاتلي.
Brother's coming.
إيميلي دو شاتلي كان لها تأثير كبير في الفيزياء خلال حياتها القصيرة. تلك المرأة التي لم يسمع بها أهل زمنها نشرت عددا من البحوث العلمية، من بينها ترجمة مؤلف إسحاق نيوتن المبادئ، وهو أعظم بحث حول الحركة كتب يوما. ما زالت ترجمتها نصا نموذجيا في فرنسا حتى هذا اليوم.
In one sense, she is a woman utterly out of her true time and place. She's a philosopher, a scientist, a mathematician, a linguist. She demands a freedom that women didn't begin to enjoy until over 150 years later. A freedom to study science, to write about it, and to be published.
تزوجت إيميلي في 19 من عمرها من جنرال في الجيش الفرنسي، وأنجبت 3 أطفال. كان